One of the common uses for this system is assessing surface finish, in particular surface roughness. Here on the table I have several different metal parts that have different amounts of machining. And we can use this system to characterize that. First I'll press it into this surface, and I'll make a measurement. And here is a second surface with different machining marks. After we have our measurements, we have a variety of ways that we can analyze them. One of the simplest things to do is look at roughness, like RA or SA. And in many cases, that's sufficient, because there might be a spec on what the RA or SA needs to be for this component. But in other applications, where the surface finish is not as well described by those parameters, we've had great success with a new AI module that we've built into our software, where you can train the system by capturing hundreds of measurements of part A, hundreds of measurements of part B, and the system will learn to distinguish those. But first, I'm going to just show how these two parts differ for both RA and SA. In our software, we can open these measurements and look at different types of roughness. First, I'll start with profile roughness. With our profile roughness tool, we draw a line across the surface, and it tells us the RA. Here it says 6.77 microns. With our roughness tool, because our system measures a full area, we can calculate more than just the RA of a single trace. Here I'm showing that we can calculate 11 traces over a 2.5 millimeter area, and the average RA of 6.8 microns. This produces a more robust and repeatable measurement, and it's something that would take a long time to do with a traditional roughness measurement tool like a stylus profilometer. Because we have an area, we can also calculate areal surface parameters such as SA and SC. Here's an example of calculating the SA of the surface. And you can see that this can be a richer description of the surface that's not as susceptible to the direction at which somebody draws the line. Now, I had also measured this other part, which has different surface characteristics. So I'll do the same measurements in this part. Here we can see the roughness goes in a different orientation. So the natural orientation of this roughness is vertical. You can see it's a much smoother part with an average RA of about 2 microns. I can also choose to do multiple profiles as I did before. And I can also do SA. So as you can see with our tool, it's a very fast way to measure roughness parameters of a surface, and much faster than competing instruments, which often exist in labs. This is a tool that can be down on the factory floor, can be used in a handheld setting, and has a relatively large area. It measures approximately 8 millimeters by about 5 millimeters in its area. So while I just showed some basic examples of measuring a defect and measuring roughness, the tool is actually useful for a wide variety of tasks. You can look at the quality of engraving. You can look at chamfers. You can look at hole diameters, hole circularity. There's plenty of interesting things that exist on the surfaces of components, and we'd love to hear about new applications that you might come up with. Thank you for your attention.